So we're back to our ways to represent relations, and so on the back side of this, in the last video we went through and we discussed kind of how to do a discrete set of relations, just a few points. How do we write them as an ordered pair? How do we split them into domain and range? Table, map, graph, how do we see that they're a function or not? And so we're going to do the same thing, but now we're going to look at a couple of different examples. Still the ordered pairs and the tables and the maps like we did, which are going to be discrete numbers, but now we're going to also include the graphs and the equations. Okay, so we're going to start over here with the ordered pairs. So when you have the ordered pairs here, we're going to have a -1 and 2. That's our x value and a y value. Okay, remember that. We have an x and a y here and an x and a y here. That's how ordered pairs work. Okay, and so there are 3 ordered pairs in this particular relation, and that's the only 3 points that are in it. So when we go to write our domain, we're going to pull out each of the x values. So we have a -1, a 0, and a 2. Those are the 3 x values. So I'm going to put them in order from least to greatest in my curly braces. The curly braces represent the domain. So -1, 0, and 2. Okay, that is the domain. Now, when we go to do the range, we're going to look for the y values. Here we have a 2, a 5, and a 7. And so again, we're going to put those in order from least to greatest. 2, a 5, and a 7. When we're looking at ordered pairs to tell whether something is a function or not, we want to look at those x values. And if that x value is repeated anywhere, we're not worried about the y values, just the x value. If the x value is repeated anywhere, then it is a function, is not a function. If the x values are not repeated and they're used only once, then it is a function. So in this case, we have a -1, a 0, and a 2. All 3 numbers are different. They're only used once, so this is a function. Okay, so that's how we work with ordered pairs. Ordered pairs are going to be a discrete set of data. There are only going to be a set number of them and not any decimals or fractions in between them. Okay. All right, now tables. Tables are going to be also a discrete set of data, so you're only going to have a specific number of points. And tables are nice when you're doing your domain range because they're already listed all on one side. Very easy to see. That's my domain. That's my range. And so when I go to write them, all I have to do is make sure that they're in order from least to greatest. So here I have a -2. That's my smallest number. Then I have a 0. And then I have a 3 and another 3. And when I have 2 of them, I only have to write it once. So I ended up with -2, 0, and 3. That's my domain. Now on the range, I'm going to do the same thing. I'm going to start with the smallest number, which is -4, and then 1, and then 2, and then 6. And the question is it a function? So again, it's really nice to look at tables because all of your x values are laid up right here. You notice that there are 2 different 3s. They both have a different y value. So this is not a function because we don't want x values that repeat. We want them to be just one y value per x value. Okay. Now, mapping is also going to be discrete values, a discrete set of values, because we only have a few numbers. I couldn't possibly list every all real number that falls on a graph of y equals x. And that would be every possible imaginable number. It's all real numbers. And so that's why with the mapping it has to be discrete. There's just a set number, a finite number of ordered pairs. Okay. So our domain here, also mappings are really nice because your domains are already listed in one spot. Here they are, -7, 0, 3, and they're already in order. So -7, 0, and 3. And then over here I have this mapping for my range, 1 and 2. Again, already in order from least to greatest. So those are really nice for copying down domain and range. Now for function, we'll look here. -7 goes to 2, 0 goes to 2, and 3 goes to 1. So if you wanted to write down those ordered pairs, it'd be easy to see them. There's -7 and 2, 0 and 2, and 3, 1. And you'll notice that none of those ordered pairs have the same x value. They have the same y value, but none of them have the same x value. So because they're all 3 different and they don't share, it is a function. Okay. Now, the last 2 ways that we represent relations are generally going to fall under a continuous set of numbers, which we're not really ready to talk about yet in class. But for the purpose of these notes, I'm going to go ahead and buzz through this so that when we do come back to it, you'll already have these notes and you can kind of fill them in and know what's going on. So, equations are another way that we do represent relations. And so, when we take an equation, we're going to look, we're just going to graph it on our calculator. So I'm going to go to y equals, and I'm going to type in x squared minus 1. So x squared minus 1, and I'm going to hit graph so I can see this graph. Okay, so here it is. Now what you'll notice is that this graph goes on forever, up and out, and on forever, up and out. So if I'm looking at domain, I'm looking at where are the x values, where are there going to be points on this x-axis, not necessarily on the x-axis, but where are we going to have x values, x coordinates for this line. And so if you look, because it's going up and out to the right and up and out to the left, then those x values are going to go in both directions forever. So when our domain, we're going to be looking at every possible number that exists from negative infinity all the way to positive infinity, because that's where our graph lies, or that's where this equation represents all of those x values. And so when we do our domain, we can't just write every possible number that you can imagine. We have to write it in another format. So we use interval notation for this a lot of times, or an inequality, which we just got finished up in Unit 2 talking about inequalities and interval notation. So you could use either one of them. So for domain, I'm going to use interval notation. So from negative infinity to positive infinity, that's my domain. Every possible number, all real numbers. Now the range, you'll notice, these go up forever, but they do have a stopping point here at the bottom. So they're going to start at this -1 value. So I'm going to use a -1 as my starting point, and I'm going to go to infinity up, okay, because that's going to be my range. And we'll talk more about this when we get to this time. We'll have a few notes and helpful tricks and tips that'll help you get through this. And this is just kind of a basic overview right now. And so -1 will be our starting point, and infinity will be the ending point. And so is it a function or not? Well, when it comes to continuous graphs, we check with the vertical line test. And the vertical line test, part of your notes, your vocabulary, says that we draw a vertical line anywhere on the graph, and if that line crosses our vertical line more than one time in that vertical on that vertical line at any point, then it's not a function. And in this case, no matter where I put my vertical line, that graph only crosses it one time. So this is a function. Alright, now the last part is, let's just say we've already got it graphed. We don't actually have an equation, but we do have a graph here. So on this graph, just like we just did on the screen up here, we are going to look at our domain. So we're looking for x values. Well, they start here to the left and go to the right. That's a -4. And this is at +1. So this graph only lies on the x-axis from -4 to 1. So from -4 to +1 is my domain. Now the graph goes from here on the y-axis up to here. So at -2 up to a +3. So that's going to be my range from a -2 to a +3. And again, we'll go over some tips and tricks on how to do this when we actually study this particular section in a few days. But I just wanted you to have all of this on one paper at one time. Alright, and then is it a function or not? Well, vertical line test again, if I put my vertical line right there in the middle, well, it's going to touch here and here. It touches in two different locations, so that means that this is not a function. Okay, so again, just kind of a brief overview. We will dig deeper into this. I really want you to focus here on the top part, being able to do discrete with ordered pairs, tables, and mappings, and that's all that we're going to be doing in class. But because we needed to go ahead and complete this all at once, you'll have this when we do cover that in class.